Okay, welcome back. We're on page 632 talking about overriding methods. So we did an override. We did an override on CalcPay, and we did an override on toString. Now, toString was already overridden. So it was already overridden. So is it okay to override something that's already been overridden? Yeah, sure. It's no big deal. So that worked pretty well. So one more time, what's the difference between overriding and overloading? Ooh, overloading is when you have different method signatures, like you have a CalcPay with no arguments, and then CalcPay with one argument, and then CalcPay with three arguments. Okay, remember all that? That's overloading. And overloading has nothing to do with inheritance. Inheritance, on the other hand, the method signatures still have to match. Like this is still toString with no arguments, and this is still CalcPay with no arguments. So if there were arguments, you'd have to have them match. That kind of makes sense. Okay, so now we're going to finally circle back and talk about that protected keyword on page 461. So this is a variable, a private field variable, at least it was a private field variable. But we had to make a tweak to it so that the inherited class could see it. Now, one more time. What does private mean? Private means that only that class can see this and no one from the outside could see it at all. Okay? That's what private means. It does a pretty good job. But we needed to make an exception to the rule. We need to make it so that, okay, I still don't want people from the outside being able to see this thing, but I want all my inherited classes to be able to see it. So that's what protected is. Protected is sort of like private, except for it also allows all of the children from that. So me and all my children. Hey, All My Children, wasn't that the name of a soap opera several years ago? So the idea is all the child ones, all of those subclasses can see this thing. So I had to go back to employee and make a tweak to this to allow this to happen. I had to change these guys to protected. I didn't have to change position, last name, and first name, and imp ID because I'm not actually talking to those things. If I'm not talking to them, I'm going to leave them as private. Here, the ones I talked to PF rate and PF hours, so I need to mark those guys as protected. Okay? Cool. So, there's a little goofy diagram here that talks about it. Now, I'm going to just pretend like the default one is called a package variable. I'm going to pretend like that doesn't even exist because, quite frankly, it doesn't exist in all the other programming languages, so let's just ignore it. So, able to access from inside the same package. That's kind of a dumb one. So let's go down to here. So public, can I see this from all the rest of the classes? From an outside class? Nope. Yeah, protected? I don't like that. Actually, I'm not sure I understand what they're saying here. Accessible to a subclass outside the same package. Let's just stick with the inside the same package, okay? So, public, can you see it from the outside? Yes. I hate this. Accessible from the class package. Okay, screw this diagram. Let me just tell you. Private basically means I cannot see it from anyone other than my own class. Public means I can see it from everybody. Protected means I can see it from my own class and any derived classes. That's it. Okay? This diagram to me is not very helpful. In fact, I'm going to click off of it because the longer I stare at it, the more angry I'm going to get. Okay. So that's the idea of this new keyword. So that there are three different types of access modifiers: public, private, and protected. Okay. So let's talk about chains of inheritance. We kind of mentioned that on page 648. Is it possible for an object to derive from a derived object? And the answer is yes. Yes, it may. In other words, some class employee, and then have one employee exempt. And then you can have another one that says the employee exempt, I don't know, he's a super duper employee, so instead of getting time and a half, they get double time. So it'll be a non-exempt double or something, right? You can just keep adding, they can cascade on each other. Now, oddly enough, we've already done this because behind the scenes, not that you can see this, but behind the scenes, all classes inherit from a class called object. Okay, let's go back over here. See all this stuff like clone, equals, and finalize? Where the heck did that come from? Well, if you hover over them, it'll actually tell you where it came from. This one came from employee non-exempt. This one came from employee non-exempt. This one came from object. 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 This one came from the employee class. So, yes, we have already been inheriting from something already in a chain. So, object is the root of all classes. So, all classes inherit from object. You don't have to go up here and say extends object because it just happens automatically. Okay, kind of makes sense? Okay, so there's a key word on page 659 that talks about the instance of. That's a key word. A key word, an operator, operator like plus or minus, things like that. Okay, so let me explain what this is all about. If I go here and I want to know who the heck are you, or where'd you come from, or where are you in the descendant tree, I can say something like if imp1, and then I know this is kind of weird, but instance of, and since this is an operator, it's not like the capital O, like methods would have the camel case thing. Instance of employee non-exempt. So what do you think? What's it going to say? Yeah, it's going to say yes, it is, right? Because it is a member of that particular class. So let's just check it out. Okay. So let's run this. And say, yep, it is. Okay, let's do this again, except this time I'm going to ask it if imp1 is an employee. Ooh. Because imp1 is not really an employee. Imp1 is an employee exempt, or non-exempt rather. So I'm going to take that and say, so what's going to happen now? Is it going to say yes it is or no it's not? What do you think? It's going to say yep it is. Okay, let's go one further. Is imp an object? So what do you think? Yeah. Okay. Now, is there something kind of silly about this? And can you look at that and say, wait a minute, you're kind of pulling my leg a little bit, aren't you? Aren't all instances of a class derived from object? Yeah. So testing something to see if object is in its inheritance tree is a really stupid idea because it's always, no matter what, it'll always become true. So there's no need to ask, have you inherited from object? Because everything is inherited from object. Kind of makes sense? Okay. So I'm going to take a break for just a second and show you a little bit more complicated version of inheritance. Employee exempt was kind of easy because all it did was have to override calc pay and the toString, and that was about it. Let's do one a little bit more complicated. I'm going to do one called commission. So I'm going to go in here and say Java class, and this one's going to be employee commission. So this one is going to be different because I need to add additional things to it. Okay? So for example, the first part ought to be pretty easy. First part is going to be, I'm going to need a constructor. So, public employee commission, that part's the same, right? And then it's going to be, string first name, dang it, string last name, string position, and then I'm just going to call the super with first name, last name, position. Okay, that was easy. Woohoo! Got one of them out of the way. What did I do wrong? Huh, okay. Oh, ha ha ha. Extends employee. Okay, shoo. Can't ask for a super if you ain't got one. Let's go ahead and do the two-string one right here, right now. I mean, why not, right? So I'm gonna use the little annotation with the little app override. Then I'm gonna say public string to string, and it's gonna look almost like the previous one that we did. I'm gonna say string answer is equal to the super to string as a starting point. Then all I'm gonna do is just add to it, right? Plus equals type equals commission. Okay, and then return answer. Okay, but now count pay isn't going to work at all because they don't get paid by the number of hours they do. They get paid by a commission rate. So I'm going to go up here and give me a public final double commission rate. And let's say it's, 0.12. They get 12% commission. Make sense? Cool. So now what I need is I need to create some new getters and setters. So unlike the other one, I actually now need to go in and build something that does not exist. So I need some PFVs. So one for the commission, one for the how much sales you had, right? So I'm going to do a private double PFV sales. And then I'm going to need, some getters and setters, right? Normal stuff. So, okay, public get sales. Yikes. So this is just kind of normal stuff. And I'm just going to do return PFV sales. And then public void set sales. That sounds like a nautical thing. Double sales. I'm not going to do input validation right here while you guys are watching, but I'll do that later. And this basically going to be PFV sales is equal to sales. Okay? So now I've added two new, a getter and a setter that did not exist at all before. So now when it comes time for me to override the calc pay, again, it's not going to look anything at all like the other one. So this is going to be public double calc pay. Okay, is it possible that you could have no pay due? Yeah, I think so. So I'm not going to have an if statement here. So I'm just going to go ahead and, well, actually, we're coming up on the 15-minute mark. It won't take us very long to finish this example.